So problem 94 on page 507. 4 plus x to negative 1 over 3 plus x to negative 1.
It's on the computer. It's on the computer.
Oh, so sorry. Thank you. Sorry about that. Oh, thank you. Okay. What is the first step? What will you advise me to do?
Would that be 1 over x?
Exactly. Thank you. That is the starting point. So I have 4 plus 1 over x over 3 plus 1 over x. I will immediately state one restriction, which is perfect. And now here's your hint. I will find the LCD at the top and I will find the LCD in the denominator. Please complete all your MyLabs Plus homework between now and Monday. I already posted a lot of your homework grades because I saw many of you already finished. So I need the least common denominator for, or in the numerator, which is, good. Adjustment, please do not forget about the adjustment. If you write 4 plus 1, I cannot give any credit. So if you write here 4 plus 1, I cannot give credit. Is that clear why? Perfect. So what should I write? Very good. 4x plus 1. Perfect. Now the denominator. X. Adjustments. Good. 3x plus 1. I have now a simplified fraction at the top and a simplified fraction in the denominator. What do I do next? Copy the top and yes, x divided by 3x plus 1. But now I have a new denominator that I did not have before, so I must write one more restriction, which is, very good. And now I can only simplify what? This x with this x. Can I simplify anything from 3x plus 1 with anything from 4x plus 1? No. Very good. So 4x plus 1 over 3x plus 1 is the final answer, including this. Uh, 23 on page 508. I want to practice one more here. 23 on 508. B over A minus A over B, everything divided by 1 over B plus 1 over A. Yes, you will say A comma B not equal. Yes. Then you will tell me what? Very good. Which is? Excellent. Adjustments. The first one, what does it need? It has A. It needs B. It has B. It needs A. It has B. Good. It has A. Perfect. Can anyone give us the numerator of the numerator? Perfect. The denominator, the numerator in the denominator. Perfect. Good. Now I have a simplified form, simplified fraction at the top and simplified fraction at the denominator. How do I proceed? Copy the fraction from the top, b squared minus a squared over ab, and multiply it by, yes, ab over a plus b. I can definitely simplify what? Yes. I also have a new denominator, so I have to add this to the list of restrictions. However, if I write the simplified form as b squared minus a squared over a plus b, it's not good enough. I like the denominator, but I don't like the numerator. Can anyone explain why I wouldn't like the numerator? It's not in descending order, and when I rearrange it, there is something else I dislike about it. It has a negative leading coefficient. So I will factor it out. What is left at the top? A squared minus b squared, excellent. Oh, that problem, the last problem we did on Monday, I copied it incorrectly. So I'm gonna do that problem again. What we did is perfect, but that's not the problem from the book. So I still like to do the problem from the book. Thank you. After you left, I said, okay, maybe I copied it incorrectly, and I looked, and yes. Good. So what do I do now? What do you think I'm going to do now? Yes. How? Exactly. Therefore, getting rid of one more factor, which is final simplified form. You don't have to distribute. You can leave the negative outside and write a minus b. Of course, with the conditions, a and b cannot be 0, and a plus b cannot be 0. Any questions? Any questions? Okay, I would like now to look at equations. Please choose, if you have your book, on page 508, anything from 16 through 20. 16 through 20, and 85 and 86 on the previous page. So let me write this down for you. 85, 86 on 507, or 16 through 20 on 508. And before I forget, can anyone remind me what problem was that? What equation we were doing? We were solving an equation. Do you remember which one was the last one?
Number 31 on page 480.
Okay, so let's start with that one. So it was 2 over x minus 2 plus 1 equals x over x plus 2, and I wrote x minus 2 by mistake. Can anyone tell us the first step? Good. Then you will give me 2 restrictions. And then you will give me the LCD. Please write the equal symbol and 0 so we don't forget. Very good. They have nothing in common. It has to be the product, which means everything needs something. The first one needs, the middle one needs, yes, please multiply them because it's easier if I put it up there multiplied. I know when I multiply x plus 2 by x minus 2, I know what I get. I get x squared minus 4. Very good. And the last one needs, very good. So now please tell us what to write.
X plus X.
Good. What now? The next step? Good. But it turns out that, yes, x squared with negative x squared go away. And the positive 4 with negative 4 go away. So what is left? 4x over x minus 2 times x plus 2 equals 0 over 1. What now? Very good. We cross multiply. So what do I write? I divide both sides by 4 and I get x equals 0. First thing I check is this. Is 0 among the restrictions? No, so this must be correct. Okay, so now please choose 85, 86 on 507 or 16 through 20 on 508. We need a couple more equations. And then we'll go back to multiplying, dividing, domain. Okay, I will choose. 18. 18 on 508. A divided by A minus 3 equals A divided by A minus 3 minus 3 halves. I'm checking. A over A minus 3 equals 3 over A minus 3 minus 3 halves. 2 minutes. Okay, 3 minutes. And then I would like to look at 19. When you finish, you can continue with 19. Do we need more time? Okay, so can anyone walk me through? Please.
Move the A over minus 3 over to the side.
Good. Restriction? Yes.
3.
Good. LCD?
I would say with the A minus 3.
I see 3 fractions. I see 2 different denominators. Good. Adjustments? On the first one. On the second one. On the third one. Perfect. The top?
2a minus 3 plus 3a minus 8. That's 9.
Perfect. What now? So I have 3a minus 9 over 2a minus 3 equals 0 over 1. And now? Good. Which means a equals. However, what do I conclude? And the equation has no solution. Say it again. I am very capable of that. A over a minus 3. Oh, yes, I'm very good at that. Okay, so a over a minus 3 equals 3 over a minus 3 minus 3 halves. Sorry, we start from scratch. Sorry about that. And I looked. Twice, I may add. Thank you. So this is not 18. This is something I made up. So this is 18. So let's work on 18. Sorry. Thank you. That's possible. I don't see equal symbols, and I don't see difference. And this was negative on the right hand side. Multiplying to the left hand side, it becomes okay, that's fine. Okay, that's good. So that's why it's equals to minus 0. Yes. Perfect. Good. But you already had a minus 0. Exactly. What it does not have. Yes. You already have it. Exactly. Yep. When there are two different denominators and one of them is 1 and I have to multiply them like we had before. Depends on the problem. So if you go to this problem, you'll see what happens here. Where we come to, for this one, we have to multiply both. Because it's 1. So we have to multiply x minus 2 by x to. Yes, there is just 1 in the denominator. Yep. Okay, ready? Good. So I have a over a minus 3 over a minus 3 plus 3 over 2 equals 0. It's just a habit. I prefer everything on the left-hand side. It just doesn't matter. A not equal 3. The LCD is still 2 times a minus 3. And now this one needs, and this one needs something else. Here. 2. Here. 2. And here? Good. So what will you tell me to write? Yes. Very good. So now let's combine like terms. So this was my page 3. You said 5a minus 15 over 2 times a minus 3 equals 0 over 1. Therefore, from here, which means a equals, good. What do we conclude? Okay, problem 19, please. Do we need more time? Ready? Yes? Okay. So 19. X minus 14 over x minus 1 equals 4 minus 2x over x minus 1. First step. Good. So x minus 14 over x minus 1 minus 4 plus 2x over x minus 1 equals 0. Please do not forget this. Then, perfect.
X minus
That's it.
X minus
Good. The top.
X minus minus 14 minus 4x plus 4 plus 2x.
Do we all agree with this? Yes. Angie?
Multiplying even by 14 or 2x, or
X minus 1 is x minus 1. I only multiply by what it does not have, right? So this one has 1 and this one has 1.
yeah, gotcha.
If I multiply 14 by x minus 1, it means that the denominator is x minus 1 squared. What now? Good. I'm ready when you are.
X squared minus 3x minus 10.
Excellent. X squared, this is minus 4x plus 2x is minus 3x, and negative 14 plus 4 is negative 10. Excellent. What now? Yes, but I'll do this first because it's easier to get rid of the denominator, actually. So then what is the new equation that I have to solve?
X squared minus 3x minus 10 equals 0. X minus 5 times x plus 2. 5 and negative 2.
Is it a yes or a no?
Yes.
Do you think we need more rational equations? Are we okay with them? Because I like to review everything, and if we have time, we can come back and do more. Did we get the idea? One more time, this is not a trivial problem. Not too many students can brag with knowing this. Yes, please choose. Absolutely. Please choose. It's not an easy problem. I hope you agree. We have so many steps. You have to go through a lot of thinking. Okay, ready? Which one?
I'll say 21.
21 is not, oh, okay, from the previous page.
Yeah, from 508.
21 is not an equation. 21 is a division of two. No, it's two rational expressions. So do we still want equations? Equations are 85 and 86, 55, 56, 57, 58 at the top, and under Chapter 7 test, 16 through 20. They have to have the equal symbol, and they have to have something on the left, something on the right.
I used to do 86.
86, very good. X divided by x plus 3 plus 4 equals x over x plus 3. Oh, I forgot here. I see. Also 47 through 52. 52 on page 506. Do we need more time? Okay. Yes? Okay, please walk me through.
So it was around
Okay. I'm assuming I copied it correctly. Am I? Or-
Yes.
Okay. In this case, this is identical with this, just a negative sign. It's like 2 minus 2, 5 minus 5. I will do this, and I conclude 4 equals 0. Is that possible? No. So of course x not equal negative 3, but no solutions. Assuming you don't see that. Assuming in a test situation, anxiety and so on and so forth, assuming we don't see that. Okay, perfect. So I study the restriction, then I find the LCD. What is the LCD? Good. So I have x plus 3. This one doesn't need anything at the top because it has the same denominator. This one doesn't need anything at the top because it has the same denominator. The only one that needs adjusting is 4 because it's 4 over 1. And it does not have x plus 3 in the denominator. So it means that I multiply the denominator by x plus 3. I have to multiply the numerator by the same thing. So then what will I have? So I have x, right, plus 4x plus 12 and minus x. Now I see that these two go away. And I have this over 1. And when I cross multiply, I get 4x plus 12 equals 0, which means x equals negative 3. And I'll say no way. No solutions. Okay, I'm not changing the rules on you, but when I see that it's the same quantity, I can eliminate it. But as I said, it may happen in a test situation or not. Okay, do you think we can put this behind us? Okay, so now you're going to have also multiplying, dividing, adding, and subtracting. So I'll let you choose. Rational expressions. Anything you want from 17 through 44. Anything that has a multiplication or a division. For example, I would choose, I think you chose 21. 21 is good. I would choose 30. So 21, I'm going to mark them down. 21, 30. And something like 42. So let's start with 21. That's a good pick. So in 21, we have x squared minus 5x minus 24 over x squared minus x minus 12 divided by x squared minus 10x plus 16 over x squared plus x minus 6. I don't want you to get confused. If you are given something like this, you are not asked to solve for x. Because at some point in time, some students change this into something else and they say x equals 5. No, this is not an equation. Here we're only asked to simplify as much as possible. So 2 minutes. These problems have a lot of work, like the equations. Why? Can anyone tell us what is the difficulty here? Everything. All these 4 expressions. Yes. Although they're not that difficult because the leading coefficient is 1. Because if the leading coefficient were 5, you would have had to use the long process, right? Don't forget to state restrictions before you change it into a product and after you change it into a product. Ready? Okay, so the top. I couldn't hear, I'm sorry.
X minus 8.
I will state restrictions. 1, 2, the same. 1, 2, 3. 3 restrictions. I know the book does not do that. It's incorrect. And I'm sure you understand why it's incorrect. One more time. X over X is 1 only if X is not 0. Otherwise, it's not 1. Okay? So, X cannot be. Very good. I am allowed not to not to simplify across in a division, but I'm allowed to simplify each fraction by itself at all times. And I am going to do this. I don't want to waste my time and write them again, because I'm simplifying something from the top with something from the bottom. However, I cannot do this in a division. I have to wait till I change it into a product. So then I copy x minus 8 over x minus 4, and I multiply it by x plus 3 over x minus 8. I have one more, or a new factor in the denominator, so I have to add one more restriction. And now I'm ready for this, and the final answer is this, including all these 4. Any questions? Is this okay? 30
Is that a 3 or a 2 that is supposed to
is the 3, this one.
would you square, would you circle around next to the equation, not that, next to that? Yes.
This one?
Is that a 3?
3 from here.
Okay, so I can tell it looked like a 2.
I would rather go back and check. Okay, x divided by x squared plus 2x minus 15 plus 5 divided by x squared plus 2x minus 15. I claim that this is not a difficult problem. Can anyone say why I claim that? The denominators are the same. I don't need LCD. It's already there. This is the LCD. So in this case, no adjustments are needed, nothing. But we need to factor, we need to state restrictions, and potentially simplify. I'm copying 42. After this, I'd like to look at some domain problem. And then I would like to go back to chapter 12. Because I have about 40 minutes. 35 minutes I need to go back to chapter 12. Okay, can anyone factor this for us? Very good. Then you will give two restrictions. Okay, no adjustments are needed. What now? That's why I write the 1. I have students, or from my experience from my past classes, I have students who write this. This is incorrect. When I divide x plus 5 by itself, I don't get 0, I get 1. When I divide x plus 5 by itself, I get 1. So please do not write 0. That would be incorrect. Some students come up with the answer as being x minus 3. You cannot move x minus 3 from the denominator to the numerator. So please do not consider that if there is 1 in the numerator, automatically whatever you have in the denominator, you can freely put it up. So I'm telling you from the experience I have. So this is 1 over x minus 3, not x minus 3, and not 0 over x minus 3. Okay, this one. Last one from chapter. I want a domain. I'm looking for a domain function problem. Yeah, for example, 6 on 505. And then we go back to chapter 12. Can anyone get us started on this one?
X plus 4, x minus 2. X minus 2, x minus 2.
Very good. So how many restrictions will you give? Exactly. -4, 2, and 1. Excellent. What is the LCD? Very good. Excellent. Adjustments, please. One more time, if you make the mistake, please don't. But if you make the mistake to write 3 plus 2, which is 5 at the top, I cannot give any credit.
X minus 1.
So this needs an x minus 1 because it does not have it in the denominator, correct?
X plus 4.
And x plus 4 for the last one, for the second one, because it does not have it in the denominator. Excellent. So then the numerator becomes, very good, and finally, so 5x plus 5 over x plus 4, x minus 1, x minus 2. Even if you factor out a 5, which I would do, you cannot simplify it with any factor from the denominator. This is it. So this, including this. Final question from this chapter. We are given a function. We're asked to find the domain. Find domain of G. What do I have to write in order to find the domain? I have to write something, solve that something, and then I'll get the domain. Exactly. 3x squared minus 48 not equal 0. How do I solve this equation? I want to simplify it if I can. I can never divide by x or x squared or any combination with x. But I can simplify it dividing both sides by, yes, I will divide both sides by 3. What do I have left? Very good. Now I have to remember what? How to do what? How to factor. How do I factor x squared minus 16? So I have two options. X cannot be and x cannot be. 4 and negative 4. Now I'm capable of writing the domain. Because I know the domain in plain English will be anything but negative infinity, comma, union. Careful. Perfect. It's very easy to make that error and consider the in-between is gone. So please don't. Okay, perfect. Do you think we need more examples? Yes, please. Angie?
For this one, which one go top of the 3x?
Remember, this is a question on the domain. We are only asked what I can plug in. And the answer is I can plug in anything except those values that make this 0. The top is free. The top has no restrictions ever on a rational function. Only the denominator could be the problem. If the denominator could be 0, then I have to exclude it. Okay, are we finished with chapter 7? Yes? Yes? Okay, chapter 12 now. I am on page 773. I'm looking at 773. This is the chapter 12 review. And I will remind you, we only studied the following sections: 12.1 to 12.3, 12.5, and 12.7. Okay, I will start with 12.1 on page 773. We are given two functions. Let's say problem 4. We are given f of x, which is x minus 5, and g of x, which is 2x plus 1. We're asked to find g over f of x. And I will also add, find its domain as well. How do I find g over f? I have to write the definition so I don't make a mistake. What is g over f equal to? What does it equal to?
2x plus 1.
G of x over f of x, right? But I have to write the definition first. I'm not going to deduct points if you don't write the definition, but it's always good to write it first. And now you're right, 2x plus 1 over x minus 5. Now I'm going to ask you, what is the domain of this new function that we just created? Exactly. X minus 5 cannot be 0, which means x cannot be 5. We agree? Okay. I would like to look at problem 5. In problem 5, we are given two other functions. We are given f of x, which is x squared minus 2, and we are given g of x, which is x plus 1. We are also given h of x, which is x cubed minus x squared. And I would like to determine f comp g of x. By definition, what does this mean? I have to write the definition so I don't make a mistake.
This will be
F of g of x. Where do I start? Where is the starting point? What do I have to write next? No, I have to replace g. What does g equal to? So this is f of x plus 1. Now I look at f. F says whatever squared minus 2. Please dictate. Give me the whatever squared minus 2. So f of whatever is whatever squared minus 2. I have to square x plus 1. And I know you're not going to say x squared plus 1, right? Because a binomial squared has 3 terms. So when I square x plus 1, what do I get? So now I combine like terms. So this is x squared plus 2x minus 1. I would like to look at problem 10. Please stop me if you have questions. In problem 10, we are asked to find h comp h of 2. What do I have to write first? Exactly. H of 2. Where do I start? Where is my starting point? So I have to find this, right? Because I have to put it in here. So let's look at h. Can anyone give us h of 2? How will you determine it? How much is 2 cubed? 8 minus 2 squared. Good. So the answer is? So what am I looking for now? H of 4. Excellent. So now I go back. 4 to the third. Let's write it. 4 to the third minus 4 squared. How much is 4 to the third? Perfect. How much is 4 squared? So 48 minus 16, 64 minus 16 is 48. Good. Problem 16. Any questions? Any questions? Problem 16. Same page. We are given f of x, which is the square root of x plus 2. And we're asked to find f of negative 1, in part A, and in part B, f inverse of 1. We are told that this is a one-to-one function. So, how do I determine f of -1? Good. The square root of -1 plus 2. This is the square root of 1, which is 1. So this function is applied to -1 and returns 1. Now we're asked to find f inverse of 1. What will that equal to? The function is applied to -1 and returns 1. Now we want the inverse function to be applied to 1. What would the answer be? Of course. Absolutely. Perfect. Very good. Find an equation defining the inverse function of the given one-to-one. So we are given, let's say, 28. We are given r of x equals 13x minus 5, everything over 2. We are told this function is one-to-one. Find its inverse. How do I determine the inverse of a one-to-one function? That is a 4-step procedure. What is the first step? Yes. Step 1, y equals 13x minus 5 over 2. And step 2, I interchange. Good. Step 3. Exactly. Well, I know what this is. What is it? Proportion. What do I do with a proportion? And only in a proportion. Good. So then 2x equals, I'm solving for y. What should I do next?
And 5 equals 7.
So that's the final step. Step 4, I replace y by f inverse. 2x plus 5 over 13. I'll see you on Monday. Please review everything.
Okay, thank you.
Thank you. Good. Solve each equation for x from 31 through 36, and then I would like to look at the graph. 31 through 36, section 12.3. 31 to 36 on 773. Please check. Which one?
33.
33 it is. Very good. 2, 33. Raised to 3x equals 1 over 16. Let's think for a minute. We had something similar on a quiz, on a previous quiz. Very important type of equation. Can anyone tell us what type it is? Exponential. The variable is at the exponent level. It is an exponential equation. Very good. Okay. what will you do? How will you think about this? Try to present both sides with the same base. So this is already done. It's 2. You cannot do anything else to 2. But 1 over 16 is not done. So the left-hand side is 2 to 3x, and the right-hand side is? Indeed. Please carefully think or look here. I'm not dividing by the base. I'm not eliminating the base. No, that's not allowed. Here's how we think. 2 numbers are equal, right here. 2 numbers are equal, and they have the same base. What has to happen to their exponents? They have to equal each other, which means, what should I write? Therefore, x equals? Good. Other equations. And then I would like to look at a graph. 35. Very good. 9 raised to x plus 1 equals 243. Again, what type of equation is this? Exponential. That's why I need to make both sides with the same base. This doesn't always happen, but in our course, we're only learning the simple equations. It is always wise, I shouldn't say always, but most of the time is wise to use prime numbers as the base. Not use 4, not use 9, 16. Although it could work, please always think in terms of prime numbers. So I would always think in terms of 3 to some power, because it's 9. So it's 3 squared raised to x plus 1. What about the right-hand side?
3 to the 5th.
3 to the 5th? Good. Now, this is not enough because I have to copy the base and do something with these exponents. What do I do with them? Yes. So I have to distribute 2 to x plus 1. What do I get? Now, one more time. 2 numbers are equal. Right here. They are equal. And they have the same base. What has to happen to their exponents? So 2x must equal positive 3. X equals 3/2. Do we want more equations or we move on to graphing? Please choose. Bless you. Bless you. Which one? 36 it is. So 8 to 3x minus 2 equals 4. Okay, 2 minutes.
You take 243 and you say 2 plus 4 is 6, 6 plus 3 is 9. Therefore, since 9 is divisible by 3, so will 243. So I'll say 3. 24 divided by 3 is 8. 3 divided by 3 is 1. So 3 times 81 is 243. Now 81, I know is divisible by 3. 27. 27 I know is divisible by 3. 3 and 9. 9 I know is divisible by 3. And I'm done. 1, 2, 3,
prime factorization of a number. Is that okay? Good. Can anyone give us the left-hand side? Very good. Everything raised to 3x minus 2. Can anyone give us the right-hand side? Good. So now the left-hand side, 2 raised to, and the right-hand side, 2 squared. One more time. Because I shouldn't, but it is possible that I'll see this. No, this is not what we're doing. We're not dividing both sides by the base, okay? Two numbers are equal. Their bases are the same. What has to happen to their exponents? Yes. So 9x minus 6 must equal 2, or 9x must equal 8. So x equals 8 divided by 9. Do we need more equations, or we move on to a graph? Okay. So I would like us to choose from 37 through 40. Graph each exponential function. Okay, 38. So y equals 1/3 raised to the x power. Good. Let's pick some numbers. What is the domain of this function? What can x be? Are there any restrictions on the exponent? No, they're not. So the domain is all real numbers. Good. So let's just pick -2, -1, 0, 1, and 2. So if I plug in -2, what do I get? So I have 1 divided by 3 raised to -2. I know that 1 divided by 3 can be rewritten how? Very good. I copy the base. What happens to the exponents? Good. So this is 9. Please plug in -1 and tell me what you get. Please plug in 0 and tell me what you get. Are we in agreement with 3? Okay. Please plug in 0. A number raised to 0, assuming the number is not 0. 1. Please plug in 1. Perfect. Please plug in 2. Very good. Very good. So let's graph. First order pair. One, 2, 3, 4, 5, 6, 7, 8, 9. Good. Second order pair. Next ordered pair. Next ordered pair. Yep. And now it's becoming difficult. So this is the graph of 1/3 to the x. I want to show you also with the graphing calculator because I don't remember if we did. Because I would like to. We need to check. So in y equals, in parentheses, put 1 divided by 3, close the parenthesis, put the power symbol, and in parentheses put x. This is the key for x, next to alpha. This one, the first one, where it says x, t, theta, n. Now, go to Zoom and choose standard, number 6. The graph does not touch the x-axis. That's because it's so close, but it does not touch the x-axis. If you want, we can enlarge this in here, zoom in, and you'll see it's moving further to the right. The closer. It gets closer and closer, further to the right. So this is the graph. This is the correct graph. But you can check with the graphing calculator and graph the function. Okay? Any questions? Good. Can we move on? We move on? Okay, very good. Page 774. We are looking at section 12.5 now. Monday, please review everything. So I'm looking at problems 47 through 62. On page 774. Let's look at write each equation with log notation. The most important concept here in this chapter is the relationship between an exponential and a log equation, right? So if I have log base b of x is y, this is equivalent to, we always start with the base counterclockwise. What do I have to write?
B to the power of 1 equals x.
Excellent. So now when I'm given this equation, it's an exponential equation. I will put it here on this side. 2 to negative 4 equals 1 over 16. After I write my notation, my conversion, the most important concept. And then I'll say log of something applied to something equals something. And now from here, I can come up with this. Because I know this raised to this is that. So what is the base? What is this number? And what is this number? That's it. Okay, one more, like 47. We are given 49 equals 7 squared. I don't like the way it's arranged because it may be confusing to me. So I'm going to arrange it as 7 squared equals 49. And now I know I have log of something applied to something equals something. What is the base? What number do I raise it to? And the answer is, that's it. Now I would like you to choose from logarithmic equations. Very important, 51 through 62. We have not studied 57 and 58, so you don't have to choose those. You're not going to get something like that. Oh, let's do as many as we can here. 52. Log base 3 of x is 2. I know that this is equivalent to very good. So I know what x is. 9. That's it. 54. Log base 4 of 64 is x. I know this is equivalent to
4x equals
4
6 x.
raised, not 4x.
19.
Okay, I'm sorry, I thought you said 4 times x. Okay, very good. So I'm not saying that Aaron said that, but please do not ever say 4 times x equals 64. It's 4 raised to power x equals 64. Good. So now I know that I have to present both sides with the same base. Yes, in this case, 4 will work. I highly recommend prime numbers, but 4 will work, so I have to agree with that. So what is the right-hand side? Good. Two numbers are equal and they have the same base. What has to happen to their exponents? And the number has to be 3. Very good. 60. Log base 3 of 2x plus 5 equals 2. And this is equivalent to
3 squared equals 2x plus 5.
so 9 equals 2x plus 5. Then 4 equals 2x. Then x equals 2. When we solve logarithmic equations, we should always go back and check. It's part of the problem. So 2 times 2 is 4. 4 times plus 3 is 9. Is 3 squared 9? Yes. Good. One more here. 62. Log base 8 of x squared plus 7x equals 1. This is equivalent to
X, what would be 8? Sorry.
8 equals.
X squared plus 7.
Good. What do I do now?
Move 8 to the other side.
Minus 1 plus 1.
I have to check. So let's go back. 64 minus minus 56. It's 8. Is 8 raised to the first power 8? 1. 1 plus 7 is 8. Is 8 to the first power 8? Both work. Okay, final section, 12.7. 79. Use a calculator to approximate the log to 4 decimal places. So common log of 3.6, and I would like to look at 82, which is natural log of 4.63. So with the calculator, so let's second and quit. So clear if you have anything else. Log, LOG is right here. LOG, common log. 3.6, close the parenthesis and press enter. And then the other one, natural log, ln, right here, in parentheses, 4.63, and close the parenthesis. So the first one was 0.5563. They want 4 decimal. I said 4, right? Yes, correct. So the first one is 0.5563, and the second one is 1.5326. One type of problem that I did not see here is when, let me find one. When two functions are given and we're asked to show whether they are inverses of each other. Okay. Yes. Problem 48 on page 728. F of x equals 3x minus 10, and g of x equals x plus 10 over 3. We are asked to check whether they are inverses of each other or not. What do I have to do? Please redo all quizzes, print out all blank quizzes, and redo them, and all tests in preparation for the final exam, please. Okay, so I'm given f and g. In which situation two functions are inverses of each other? Only when I give you $10 and I take it back. No deal. How do I show whether these two are inverses of each other without finding the inverse of this and say, hey, it's x plus 10 over 3? No. Or finding the inverse of this and say, hey, it's 3x minus 10. No. I want to show that they are inverses of each other without finding the inverse of either one. Nope. How do we know when two functions are inverses of each other?
Nothing happens to x.
Say it again.
When nothing happens to x.
Right. Which means I apply f and then I apply g. Nothing happens to x. I apply g and then I apply f. Nothing happens to x. So what does that mean? What operation is that? When I apply f and then I apply g. It's not addition, it's not subtraction, it's not multiplication, it's not division. But the fifth method of finding functions. What is that fifth method? Composition. So I have to find f comp g, and I have to find g comp f, and I have to show that both in other direction, both will equal definitely x cubed. No. X over 5. No. The square root of x. No. Exactly what? Plain x. Though only then I know that they cancel their effect on x. One annul the effect of the other. Okay, good. So then I need to find f comp g. By definition, what does this mean? Very good. F of g of x, which means f of, very good. Now I look at f. F tells us this, 3 times whatever minus 10. How do I write that? 3 times x plus 10 over 3 minus 10. What do I have to do next? It's 3 over 1. So simplify by 3 because it's a factor. What is left? What is the answer? As expected. But I still have to show the other one. So g comp f. The definition.
G of X.
Very good. G of 3x minus 10. And now I look at G. G says whatever plus 10 over 3. How do I write whatever plus 10 over 3?
3x minus 10 plus 10 over 3.
What do I have to do first? I cannot just yet. I have to simplify negative 10 and 10. Because I cannot simplify in a sum. And now I can simplify factors. I'm allowed to. The answer is, what do we conclude? Are these inverses of each other? Can I say now for sure that this is F inverse?
Yes.
It's F inverse, which is x plus 10 over 3. Can I also say that this is G inverse? Yes, 3x minus 10. This will not have happened if these two functions were not inverses of each other. We would have gotten x plus 5 or x squared over 3 or the square root of 5, x minus whatever else, but not x. Since both function compositions were x, we conclude that f and g are inverses of each other. I applied f and then I applied g. Any questions? I forgot to take attendance. I cannot think of anything else unless you have questions. Is there any particular type of problem that you would like to go back to?
Word problems or typo word problems or this test?
We have not had word problems in chapter 7, and I don't think we had. Did we have anything in chapter?
They threw some in when I class.
The ones with the formula, just to plug in a formula. Yeah, we can look at that. Yeah, the formula will be given to you. So let's look. And let me tell me if you recognize those. The interest.
Yeah, pages E, it's like, there are a bunch of those.
You mean like 41 and 42 on page 773? Is that what you had in mind? Okay, very good. So very good. Thank you for reminding me. Find the amount accrued, number 41.
They always had us do semi-annual, quarterly,
Yes, very good.
semi-annual, quarterly, and then continuous.
Very good. So 41. The formula will be given to you. 1 plus r over n raised to nt. Find the amount accrued if the principal is 1,600, is invested at the rate of 0.09 or 9%, compounded semi-annually. What does that mean, semi-annually?
Twice.
Twice per year, and for 7 years. So that will be A equals 1,600, and in parentheses, 1 plus 0.09 divided by 2, everything raised to 2 times 7. So let's see how we put this in the graphing calculator. Thank you so much for reminding me. So 1600 in parentheses 1 plus 0.09 divided by 2, close the parenthesis, power, which is caret, in parentheses 2 times 7, or you can write 14, and press enter. So the accumulated value in 7 years will be approximately 2963.11. Let's also do 42. A total of $800 of principal, 800, is invested in a 7% certificate of deposit, so 0.07 for R, for which interest is compounded quarterly. So N means how many quarters are in a year? 4. Find the value that this certificate will have at the end of 5 years. So T equals 5 years. I put in the formula as 800 in parentheses 1 plus 0.07 divided by 4 to the power 4, which is N, times T, which is 5. Again, I have to put in the graphing calculator all at once. Do not do it step by step. You're going to put error in the answer. So 800 in parentheses 1 plus 0.07 divided by 4, close the parenthesis, and then put the power, which is caret, in parentheses. You can write 20, but if you want to keep it as is, 4 times 5, close the parenthesis and press enter. So we will end up paying back or getting, depending on what we're doing. So A is approximately 1131.82. So the trick is to put everything at once. Do not perform the parenthesis, then you find with the power, and then you multiply by 800. No, it has to be done all at once, so you don't put in error. Was there anything else that I did not touch up on? Okay. Thank you so much for coming. I will see you